So, question 1, we have to follow BIDMAS because we've got various operations going on. And remember, with BIDMAS, this means we do any brackets first, then indices, that's powers, then division, then multiplication, then addition and subtraction. So with question number 1, we've got to start off with indices because we don't have any brackets. So the squaring will come first, secondly will come the multiplication, and only thirdly will come in the addition. So the squaring comes first, 3 squared, remember that means 3 times 3, which is 9. Then secondly we do the multiplication, 4 5s are 20, and only thirdly do we do the addition, 9 add 20 equals 29. Question 2, so another BIDMAS question. Now on this occasion we do have brackets, so whatever is in the brackets has to come first. What's inside the brackets, that's an addition. So that will come first. Secondly will come the indices, the squaring, and thirdly will come the division. So starting off with what's in the brackets, 3 add 5 is 8. Secondly we do the squaring, 8 squared means 8 times 8, which is 64. And only thirdly do we do the division, 64 divided by 4 is 16. Question 3. So whatever's in the brackets is going to come first, and then the subtraction second. So what's in the brackets is 9 times 0.3. So be careful here. 9 times 3 is 27, but we've got 0.3, which is a tenth of 3. So our answer is going to be a tenth of 27, which is 2.7. So it makes sense that our number we get from doing this multiplication is less than 9, because 0.3 is giving us a fraction of 9, so we would expect our answer there to be less than 9. So anyway, the multiplication gives us 2.7. Then secondly, we have to then subtract the 0.5. 2.7 minus 0.5 is 2.2. Question 4. Well, 7 squared simply means 7 times itself. So 7 times 7, which is 49. Question 5. Which of these numbers is a cube number? Now remember, a cube number is what you get when you take a number, you multiply it by itself and multiply by itself again. So for example, 27 is a cube number because 3 times 3 times 3 is 27. Now of the 4 numbers we're shown, 125 is the only cube number because 5 times 5 times 5 is 125. So 125 is a cube number. 5 cubed is 125. Question 6. So circle the prime number in the list below. Now remember, a prime number is a number that you can only get when you're multiplying 2 whole numbers together, when those 2 numbers are 1 and itself. So for example, 11 is prime because 1 times 11 is the only way you can get 11 by multiplying 2 whole numbers together. So looking at these, let's look at the 3 which are not prime. 9 is not prime because apart from 1 times 9, you've also got 3 times 3. 21 is not prime because as well as 1 times 21, you've got 3 times 7, and with 25 you've also got 5 times 5. So 17 is the only prime number because the only way you can obtain 17 when multiplying 2 whole numbers together is 1 and 17 itself. Question 7. Anne-Marie wrote down the factors 30 of 32. Which factor is missing from a list? We'll always try and do the factors in pairs. So we've got 1 times 32 is 32. So 1 and 32 are factors. 2 times 16 is 32. So 2 and 16 are factors. And then finally 4 times 8 is 32. So the missing factor from Anne-Marie's list is 8. Question 8. Circle the number below which is not a multiple of 3. Well, one little trick when trying to work out what's a multiple of 3 or not is to add the digits together, and if the total of those digits is divisible by 3, then the number itself is divisible by 3. So for example, 396, if you add the 3 digits together, 3 add 9 add 6, you get 18, and 18 is divisible by 3, so therefore 396 must be divisible by 3. Same with 537, because those 3 digits add up to 15, which is divisible by 3, and the same with 207, because 2 add 0 add 7 is 9, which is of course divisible by 3. So the only number here which is not divisible by 3 is 463, because you add those 3 digits together you get 13, and 13 is not divisible by 3. Question 9. So, circle the square numbers appearing in the list below. So a square number is a number you get when you times a number by itself. So we've got 3 square numbers here because 6 times 6 is 36, 11 times 11 is 121, and 15 times 15 is 225. So 36, 121 and 225 are square numbers. Question 10. 3 of these fractions are equivalent, which is the odd one out? So let's go and simplify all of them and see what we're left with. Well, 6 over 8, we can divide numerator and denominator, that's top and bottom, by 2, giving us 3 over 4, 3/4. With this second one, we can divide top and bottom by 3, which gives us 6 over 8, and then we can halve top and bottom to give us 3 over 4. Was this third one? Well, let's just work our way down. Let's halve top and bottom first of all, 12 over 16. Let's halve top and bottom again, 6 over 8. And we can still halve top and bottom, another 3 over 4. So the first 3 numbers here all simplified to 3/4. Whereas with the last one, if we halve top and bottom, we get 14 over 18. If we then go and halve top and bottom again, we get 7 over 9, and that can't be simplified any further. So which is the odd one out? 28 over 36 is the odd one out, because that does not simplify to 3/4. Question 11, put the following fractions in order. Now a lot of you might be able to just sort of put them in order just by sight and just comparing one with another. But one way to do it, just to be absolutely sure, is to put them all over a common denominator. Now I can see that 6, 8, 4, 12 and 3 are all factors of 24. So I'm going to go and pop all of these fractions over 24. I'm going to find the equivalent fraction for each over 24. So starting off with 5 over 6. To convert a 6 to 24 I need to multiply by 4. So multiplying top and bottom by 4, 5 fours are 20. So 20 over 24 is an equivalent fraction. With the second one I need to multiply the denominator, the bottom number, by 3 to get 24. So let's time the top by 3 as well. 3 3s are 9. The third one I times top and bottom by 6. The fourth one top and bottom by 2. And the fifth one top and bottom by 8. So that gives me 5 equivalent fractions all over 24, which I can contrast easily. So the smallest one is 6 over 24, then 9 over 24, then 10 over 24, then 16 over 24, then 20 over 24. So that's my order. So putting the fractions in order, I get 1/4, then 3/8, then 5/12, then 2/3, and then finally 5/6. Question 12. So we've got to turn 2 4/9 into an improper fraction. That's a top-heavy fraction. Now, doing it the longer way, which is sort of properly understanding it, we need to turn this into ninths. Now, every whole is going to be 9/9. So if we've got 2 wholes, that's 2 lots of 9/9. So that's going to be 18/9. So 2 wholes is 18/9. Then we've got another 4 as well. 18 plus 4 is 22. So our final answer is 22/9. Now the quick way to do it, really sort of summarising what I just said, just do 2 times the denominator, 2 9s are 18, and add the 4 to give us 22. So 22 over 9. Question 13. So when we're adding or subtracting fractions, we have to have a common denominator. That means we have to have the same number on the bottom. So what do 3 and 5 both go into? They both go into 15. So that's the lowest common multiplier of 3 and 5. So we're going to make both the denominators equal 15. So our equivalent fractions are both going to be over 15. So starting off with 2/3, we need to find the equivalent fraction of something over 15. So how do we convert the 3 into 15? Well, we multiply it by 5. So given that we've multiplied the denominator by 5, we've also got to multiply the numerator, the top number, by 5 as well, and 2 5s are 10. So 10/15 is an equivalent fraction to 2/3. Now moving on to the second fraction, the same method applies. 5 times 3 is 15, so we have to times top and bottom by 3, 3 3s are 9. Now that we've got the common denominator, we can just simply add the top numbers. 10 add 9 is 19, but do be careful, we do not say 15 add 15 is 30. we stay with 15 on the bottom. If you think about it, if you had a third of a pizza, then you ate another third of a pizza, that would be 2/3 of a pizza, not 2/6. Right, so we've got 19 over 15 as an answer, but we want to give our answer as a mixed number. So we've got one whole number, so we get one whole out of this using up 15/15, and that leaves 4 bits left over, so 1 and 4/15. Question 14. So here we've got to multiply fractions, and multiplying fractions is simple. It's just top times top and bottom times bottom. Now we could just simply do some side workings and work out what 45 times 7 is and 49 times 9 is, and then simplify it down. That would be absolutely fine. But perhaps an easier way to do it is to simplify down before you even start the multiplying process. So consider the two numbers on the top being times together and the two numbers on the bottom be times together. Well, we can see that 9 is a factor of both 45 and 9, so we can kick off by dividing the 45 by 9 and the 9 by 9, so these can really cancel down to becoming, instead of 45 and 9, we can say 5 and 1, because overall we've divided the numerator by 9 and we've divided the denominator by 9, so nothing's changed overall. Similarly with the 7 and the 49, we can choose to divide both of these by 7, giving us 1 and 7. So with these two simplifications, we're left with 5 times 1 over 7 times 1, which is of course just 5/7. Question 15. Now to divide fractions, you've just got to follow a process. The first fraction stays the same. You change the question from being a division to a multiplication, and you flip the second fraction, and the second fraction only, over. So rather than 5 over 6, that becomes 6 over 5. Now that's then just changed the question into an easy multiplication question, which is just top times top and bottom times bottom. 3 6s are 18, 4 5s are 20, and then we can just simplify top and bottom by dividing both by 2, giving us 9/10. Question 16. So before we do any operation when we've got mixed numbers, step 1, whether we're multiplying, dividing, adding and subtracting, should always be to change your mixed numbers into improper top-heavy fractions. So let's just start off by doing that. So 1 and 3/7 is 10/7. 1 7 is 7 and 3 is 10. And 2 and 3/4 is 11/4. 2 4s are 8, and add the 3. So we're then multiplying, so that's just top times top, bottom times bottom. 10 11s are 110, 7 4s are 28, and then we just have to simplify. So I've halved top and bottom to get 55 over 14. Now that doesn't simplify anymore, so we've then just got to break that down to a mixed number. And looking at my 14 times table, 3 lots of 14 are 42, well that's fine, but 4 lots would be 56, so that's too much. So I can squeeze 3 wholes out of this, which is using up 42 bits, so that's 13 bits left over. So that's 3 and 13/14. Question 17. So, like all fraction questions involving mixed numbers, step 1 should always be to turn the mixed number into an improper fraction, a top-heavy fraction. So 2 and 3/7 is 17 over 7. 2 7s are 14, and add 3 is 17. And 1 and 3/4 is 7 over 4. 1 4 is 4, add 3 is 7. So how do we do a division? Well, the first fraction stays the same, change it from a division to a multiplication, and flip the second fraction over. So 7 over 4 becomes 4 over 7. We've now turned it into a multiplying question, so it's just top times top, bottom times bottom. 17 times 4 is 68, and 7 7s are 49. Now we turn this improper fraction into a mixed number. We can get one whole out of this. Question 18. So we've been asked to put the following numbers into the Venn diagram. So looking at the Venn diagram, so in this big football here, we've got to put all the factors of 24 from this list, and any numbers in this list which are even, we've got to put in this football, but any numbers which are both factors of 24 and even go in the overlap bit in the middle. So working our way along. Well, 3 is a factor of 24. because 3 8s are 24, but it's not an even number, so that's why it's here. 4 is both a factor of 24, because 4 6s are 24, and even, so that goes in the middle. Now 5 is neither, so that's got to go outside the two footballs. Excuse me. 8 is both a factor of 24 and even, so in the middle. 13 is neither, so on the outside. 24 is both a factor of 24 and even, so in the middle. Now 48 is a multiple of 24. It's not a factor of 24, so it does not go in this first football, but it is an even number, so that just goes in this part of the Venn diagram. Now 12 is both a factor and even, that goes in the middle, as does 6. Now for part A, we're being asked to list the numbers in set A union B. Now A union B is all the numbers that are in both A or B or both. Now I'm taking A to be the factors of 24. I think they've just forgotten to write down that this is A. So this is obviously A, even numbers is B. So we're looking for the numbers that are in here, or in here. So that's 3, 4, 6, 8, 12, 24, 48. Now part B, list the numbers in set A intersection B. Now that's purely the bit where they overlap. So that's the 4, 6, 8, 12 and 24. Question 19. In the Venn diagram below, shade the region A intersection B. Well, that's the bit where they overlap, so that's just the bit in the middle. Question 20. In the Venn diagram below, shade the region A union B. Well, that's the region which is either A or B or both. So that's shaded region there. Question 21. So, this little dash is the complement set. That just means the bit which is not what's in the bracket. So really think about the bracket first of all. The bracket is A intersection B. So that's the little bit in the middle. Now we want everything which is not that. So that's everything in the whole of the Venn diagram shaded apart from that bit. Now do be careful. You do need to include the bits outside the rugby balls but still inside the rectangle. People often forget that. So it's not only is it including the other part of A and the other part of B, it's also including all the area on the outside. It's just basically the opposite of A intersection B. Question 22. Write down the number of lines of symmetry for the symbol. Well, the only line of symmetry is straight down the middle. Now for part B, write down the order of rotational symmetry of this quadrilateral. Now, more often than not, it is the same as the number of lines of symmetry. But what rotational symmetry actually means is if you imagine this being a shape, and then like a child's toy where you've got a hole the same shape, as you rotate this shape 360 degrees, how many times could it fit through the hole? So this shape could fit when it's as it is, but it would also fit through the hole when it was 180 degrees rotated round. So there's two ways that shape could fit through a hole of the same size as you turned it round 360 degrees. Question 23. Draw all the lines of symmetry of a square. Well, that's the two lines, the horizontal and the vertical line, but also the two diagonal lines. And really just think about it. As you folded the shape over, imagine it's a square bit of paper. If you fold along these lines, it would fold exactly onto itself with no bits sort of hanging over the edge. Now for part B, here is a rectangle. Write down the order of rotational symmetry of the rectangle. Well, as you rotated that shape through 360 degrees, it would fit through a hole of the same size twice. Question 24. Some boys and girls in a classroom. The probability of picking at random a boy is 0.35. What is the probability of picking a girl? Well, the probabilities have to add up to 1. So if part of it is 0.35, the other bit must be the bit needed to take you up to 1. So to work this out, we do 1 take away 0.35, and that gives us 0.65. Question 25. So bag contains 5 yellow, 3 red, 4 green. What is the probability that the counter chosen at random is red or yellow? Well, first of all, note that we've got 12 counters in total. Now the total number of red or yellow is 5 add 3, which is 8. So the probability of choosing a red or a yellow is 8 out of 12. So that's 8/12. And to simplify this, not that we were asked to simplify it, but if we were going to choose to simplify it, we can divide top and bottom by 4, giving us 2/3. Question 26. Now this is quite tricky, so don't worry too much if you don't follow this one. So we're told that Tim plays a game and he can either win, lose or draw, and the probability of winning is 0.25. So the first thing we can say is the probability of losing or drawing added together must be 0.75, because 0.75 add 0.25 is a whole, and probabilities always have to add up to a whole. So the question tells us that let's call the probability of losing x, and for the purposes of just explaining my answer, I'm going to let the probability of a draw be y. So we can see that x plus y must be 0.75. Now I'm being asked to give an expression in terms of x for the probability that he will draw the game. The probability of drawing is my y. So if I take my x plus y equals 0.75 and I choose to take away x from both sides, I get y being the probability of a draw to be 0.75 take away x. Question 27. So to simplify this, we've got to gather up the e's and gather up the f's. So the e's is easy. 3e plus 2e is simply 5e. Now we've got to be a bit more careful with the f's. 4f take away f is 3f. That's plus 3f. So our final answer is 5e plus 3f. Question 28. Now don't get psyched out. This is not difficult, okay? Because we're the two terms of both t squared. So we've just got 3 lots of t squared, and then we're adding on another lot of t squared. So we've just now got 4 lots of t squared. So it's just like saying we've got 3x plus x, that would be 4x, while this is just 3 lots of t squared plus 1 lot of t squared is 4 lots of t squared. Question 29. So really important algebra, this being able to solve linear equations. So remember what our goal is. Our goal is to end up with A being the subject, so A equaling something. So the way you've got to do this, you've really got to unpack the left hand side. You've got to do opposite operations to undo the -7 and to undo the 5. So the order to do things, work your way into the A. So start off with the -7, and then only as a second step sort of try and sort out the 5. So here's the first term, here's the second term, just sort out the second term first of all. So how do we undo a -7? We have to do the opposite. We choose to add 7 to both sides. So on the left that takes out the -7, just leaving us with the 5a, but on the right 13 plus 7 is 20. So we're halfway there. We've got 5a equaling 20. Now remember, 5a means 5 times a, or a times 5. How do we undo a timesing by 5? We have to divide both sides by 5. So that's what we choose to do to both sides. So that undoes the timesing by 5. So we've just left with a on the left hand side, and on the right hand side, because remember we have to do all these operations to both sides to keep things equal. So on the right hand side we've got 20 being divided by 5, which is 4. So a equals 4. And remember, you can always check your answers. Just check, is a equaling 4 the correct answer? So go back up to the top. 5 lots of a, 5 lots of 4 is 20. 20 take away 7 is indeed 13. Question 30. So similar to the previous question, start off by undoing the plus 8. So we choose to take away 8 from both sides. So that gives us 6a equaling 4. Now to undo the multiplying by 6, we divide both sides by 6. So a equals 4 to be divided by 6, which simplifies down to 2/3. Now do remember to leave your answers as fractions. Do not start turning these into decimals. There is no need, and you may get it the wrong way round, and you may lose some accuracy. Okay, so 2/3, 2/3 is a perfectly acceptable, in fact the preferred answer. Question 31. So same opening step, we need to undo the -4 by adding 4 to both sides. So at that point we're left with x over 5 equaling 6. But now for the first time we've got a different operation to undo. This is dividing by 5. So to undo a dividing by 5 we've got to choose to multiply both sides by 5. So on the left hand side that undoes the dividing by 5, so we're just left with x, and on the right hand side 6 times 5 equals 30, and again I suggest you check your answer, just check this is right. 30 divided by 5 is 6, and 6 take away 4 is indeed 2. Question 32. So we start off by undoing the -4 by choosing to add 4 to both sides. So at that point we've got 2x over 7 equaling 10. Then to undo this dividing by 7 we choose to multiply both sides by 7. So at that point we've got 2x equaling 70. And then finally to undo this timesing by 2 we choose to divide both sides by 2. So x is 70 divided by 2, which is 35. Check your answer. 2 lots of 35 is 70. 70 divided by 70 is 10. And 10 take away 4 is indeed 6. Question 33. So we've got 6 currant buns in a pack of currant buns. So if we had, say, 10 packs, that would be 60 buns. If we had 5 packs, that would be 30 buns. So what are we doing every time I tell you the number of packs? We're just multiplying it by 6. So if I tell you we've got x packs, then multiplying that by 6, that is 6x lots of buns. Same thing with the ice buns. We've got 8 ice buns in a box. So if I said to you we've got 2 boxes, you'd say 16 buns. If I said to you 10 boxes, you'd say 80 buns. But I'm saying to you y boxes, so that's 8y buns. You're just simply multiplying the number of boxes by 8. So 8y buns. So how many buns have we got altogether? We've got 6x plus 8y. Question 34. So here I'm going to let A equal Amy's age, B equals Ben's age, and C equal Chris's age. So what have I been told first of all? Ben is 3 years older than Amy. So Ben's age is Amy's age, add 3. Now what's the second fact I've been told? Chris is 10 years older than Ben. So Chris's age is Ben's age plus 10. Now just looking at this one, so C is B plus 10, but I know that B is A plus 3. So I can substitute this A plus 3 and replace the B with that. So C is also equal to A plus 3 plus 10, which is A plus 13. Or if you like, just look back to the facts. If Ben is 3 years older than Amy and Chris is 10 years older than Ben, then Chris must be 13 years older than Amy. That's all I'm saying there. Chris is 13 years older than Amy. So I've got Amy's age being A, Ben's age being A plus 3, and Chris's age being A plus 13. Now I'm told that their 3 ages together add up to 73. So A plus B plus C must equal 73. So substituting in our various facts, so A is A, well B is A plus 3, and C is A plus 13. So here I've constructed an equation where the only unknown is A. So if I simplify this, I can solve this quite easily to work out what A is, and A is Amy's age. So let's simplify the left hand side. A plus A plus A is 3A, 3 and 13 is 16. So I've got 3A plus 16 equals 73. So we can just solve this. So take away 16 from both sides, then divide both sides by 3. We get A being 57 over 3, which is 19. So Amy's age is 19. And then I've just checked I've got it right. So I'm saying Amy's age is 19. Ben is 3 years older than that, so he's 22. And then Chris is 10 years older than that, so he's 32. And those 3 ages do indeed add up to 73. Question 35. So we're given 2 facts here. We're told what the product of prime factors of 7056 is, just being this, and the product of prime factors of 168 being this. Now we're being asked, is 168 a factor of 7056? Well, so we're being asked, is this a factor of this? Well, we can see it is. all of these are parts of all of these, so therefore a factor. 2 cubed is a factor of 2 to the power of 4, because 2 cubed times 2 is 2 to the power of 4, so 2 cubed is a factor of 2 to the 4. 3 is obviously a factor of 9, of 3 times 3, because 3 times 3 is 9. And similarly, 7 is a factor of 7 squared, because 7 times 7 is 49. So as each of the components of 168 are individually factors of these components, it stands to reason that 168 must also be a factor of 7056. Now for part B, we're being asked, is 7056 a square number? So again, look at the product of prime factors. You can see that each of these powers here are even. So each of these can be split equally. We can break 2 to the power of 4 down to 2 to the power of 2 and 2 to the power of 2, 2 squared and 2 squared. We can break the 3 squared down into 3 and 3, and similarly we can halve the 7 squared down into 7 and 7. So this product of prime factors here times itself gives us this. So a number times itself gives you a square number, so therefore 7056 must be a square number. In short, if all of the powers are even, all of them, then it must be a square number. Now part C, circle all below that are a multiple of 168. So we need it to be including all of these and then numbers in addition to that. So 2 squared times 3 times 7, well that's a factor of 168, it's not a multiple of it. Now here we go, 2 cubed times 3 times 7 times 5, well that is a multiple because there's our 168 and then we're just timesing it by 5, so that is a multiple of 168. Now this third one, again this is a factor of 168, it's not equal to or bigger, it's not a multiple, that is a factor, whereas this is a multiple because we've got 2 cubed times 3 squared times 7, so that's really a 2 cubed times 3 and times 3 times 7, 8, and we're just multiplying it by 3. So where we've got product of prime factors which include all of these factors and more, that's when we've got the multiples. So these are the two multiples.